You ever do this? You look up at the night sky, see all those stars, and you just get this feeling, this nagging question? Is anybody else out there looking back at us? I mean, it's a question we've been asking forever. And today, we're going to dive into the incredible science that's actually trying to find an answer.
You know, for pretty much all of human history, asking if we're alone was a job for philosophers, for storytellers. But now it's a very serious question for scientists. And the weird thing is, the more data we get, the more we learn, the deeper the mystery actually becomes.
And the hunt for an answer isn't just happening light years away. Sometimes the most mind-blowing clues are, well, right in our own cosmic backyard. And in this case, it all comes down to one single rock on our next-door neighbor, Mars.
Okay, so this is it. The rock is named Cheyava Falls. When NASA's Perseverance rover took a closer look, it found something pretty incredible. Two minerals, vivianite and grigonite. So why is that a big deal? Well, here on Earth, you often find these exact minerals as a direct result of tiny microbes doing their thing. Now look, it's not a smoking gun, it's not definitive proof of Martian life, but scientists are calling it one of the most exciting, most tantalizing potential signs of life we have ever found. That clue from Mars is amazing, but it's just one tiny piece of this giant cosmic puzzle. Because as of mid-2025, we've confirmed the existence of nearly 6,000 planets outside our solar system. The takeaway here is just, wow. The universe isn't just full of stars, it's absolutely packed with worlds. Planets are the rule, not the exception.
So this is where it gets really interesting. We have a galaxy that is just overflowing with planets. But how on Earth do you go from there are tons of planets to a real guess at how many alien civilizations might be out there? You're gonna need a tool for that. And that tool is the Drake equation. Now, it's not designed to spit out one perfect exact number. The whole point is to break a ridiculously huge question down into smaller, more bite-sized problems. So let's walk through how a recent 2025 paper tried to solve it. All right, let's start plugging in some numbers from that paper. First up, what fraction of all those planets out there could potentially support life? You know, they're in the Goldilocks zone, not too hot, not too cold. The paper figures about 2/3 of them, so that's our starting point, right? A massive number of possible homes for life. But here's where we hit our first major hurdle. Just because a planet can have life doesn't mean it will. That initial spark, the jump from just chemistry to actual biology, is thought to be unbelievably hard. This paper gives it just a 10% chance of ever happening. And just like that, our huge number of candidates gets slashed.
Okay, next filter, intelligence. I mean, think about Earth. Life existed here for more than 3 billion years, and most of it was, pond scum. Complex, tool-using intelligence like ours is super recent and maybe super rare. So the paper estimates that on a planet that has life, the odds of that life becoming intelligent is just 1/10 of 1%.
And even if you get intelligence, that's still not enough. Dolphins are brilliant, right? But they haven't built any radio telescopes lately. So the next filter is just as tough. Only 1/10 of 1% of those intelligent species are ever expected to develop technology that we could actually detect from way out here in space. And this might be the most sobering filter of them all. Time. A civilization could be around for 1 million years, but it might only be loud, using radio technology, for a few thousand of them. This tiny number represents the fraction of a planet's entire history that a civilization is broadcasting. If their window of time and our window of time don't line up, we'd just miss each other completely. So, after all that, when you multiply all those probabilities together, the number of good planets, the chance of life, of intelligence, of technology, and for the right amount of time, what do you get? What's the final answer? According to this paper's math, it's 72. An estimated 72 communicating civilizations in our galaxy right now. 72. I mean, that feels like a lot, right? It feels like we should have heard from somebody by now. And that thought right there brings us to the very heart of this whole mystery. This is the Fermi Paradox, and it all started with this one simple question. The physicist Enrico Fermi was at lunch back in 1950, talking about the high chances of alien life, when he just stopped and asked, but where is everybody? And that one little question perfectly captured this massive cosmic contradiction. And here's the logic. It's pretty straightforward. The galaxy is ancient, billions of years old.
If a civilization popped up just a few million years before we did, they would have had more than enough time to spread out. I mean, even with slow ships, you could colonize the entire Milky Way in what is basically a blink of an eye, geologically speaking. So why is it so quiet? When you try to answer that question, the explanations tend to fall into two giant buckets. The first one is, well, that we really are alone, or at least we're the first ones to the party. Something is stopping civilizations from showing up. The second idea is that they are out there, but for whatever reason, they're choosing to stay quiet. This first idea has a name, the Great Filter. It's the theory that one of those steps we just calculated is actually a nearly impossible wall that almost no one ever gets past. Now, the good news would be if that filter is behind us, like maybe that first jump to life was the impossibly hard part and we made it. The terrifying possibility, though, is that the Great Filter is still ahead of us, some challenge that no civilization ever survives.
On the flip side, what if they're just hiding from us? One of the most fascinating and kind of creepy ideas is the zoo hypothesis. It suggests the galaxy is full of advanced life, and they've all basically agreed on a prime directive: don't mess with the new guys. In this scenario, Earth is like a protected cosmic nature preserve, and we're the main attraction. So here we are, staring out into this great silence, trying to wrap our heads around these huge possibilities. And the search goes on at every single scale you can imagine, from studying the light from distant exoplanets to drilling into rocks right here on Mars. Every new piece of data is another piece of the puzzle.
Which really leaves us with one final massive thought. Is this great cosmic silence a warning sign? A hint that the final great filter is waiting for all of us? Or is it an invitation? A quiet stage, just waiting for a species like us to finally get its act together and join the cosmic conversation.